Now we're going to talk about plate tectonics. And plate tectonics has built some of the largest landforms on the surface of the Earth, and it's also a unifying theory for geology and for physical geography in helping us explain why the world looks the way that it does. But before plate tectonics, there was this idea of continental drift. And the continental drift hypothesis is interesting to talk about because some of the ideas it got very right, but it didn't have an overall mechanism for how it would work. So in the long run, it was proven wrong. But a lot of the observations that were made and how that made sense really is still true today. And one of the things that continental drift talked about was this idea that in the past, all of the continents had been pushed together or grouped together into this supercontinent that's called Pangaea. And Pangaea was just essentially all the continents at one time in the past were all together, and it helped explain a lot of observations that people were seeing throughout the world, which we'll talk about in a minute here. The person who came up with this idea, his name was Alfred Wegener, and he was a meteorologist, so he was looking at things like the distribution of glaciers and different plants and animals, and came up with some ideas about everything would make sense about how these things were distributed on a global basis if the continents were all grouped together into the supercontinent Pangaea in the past. And these are actually some of his maps from his publications about how Pangaea looked in the past at the top and then how things started to move apart. So what were some of those observations? Well, one of it is simply the fit of the continents. It's been widely recognized for a long time that it kind of looks like South America and Africa would fit back together if just the Atlantic Ocean was not between them. The fit is even better if we go to the edge of this light blue area here, which is the edge of the continental shelf. That's really where the edge of the continent is, even though it's underwater. Sea level goes up and down over time. And the few places it really didn't fit very well were typically where rivers were depositing a lot of sediment just at the edge of the continental shelf. So it couldn't be denied that the continents seemed to fit back together in a lot of cases. Another thing would be something we call paleoclimate indicators. So paleo just means old or in the past, and climate, of course, is what the climate was like. And as you might know, we see a lot of glaciers near the South Pole on the current continent of Antarctica. And as these glaciers push away and they start to melt away, they leave evidence like piles of rocks where they've pushed all this stuff. And on the current map, we can see evidence that glaciers once pushed stuff all the way from the south end of Africa up to this area here, from the southeast coast of South America to this area here, from where current day India is up into Asia here. And all of that would make sense if these continents were at one time grouped together, and many of those continents were much further south than they are now. And so these paleoclimate indicators, also they were finding things in Norway. They were finding coal beds that had a lot of tropical plants in them, and of course Norway is no longer at a latitude where you could have tropical plants. So it made sense that maybe these continents were getting moved around over time. Another indication is these far-flung fossils that are the same species that occur very far apart. So for example, some of these things had very limited ranges, like this fossil here was only found in South America and Africa. And if we fit the continents back together, it only occurred where those two continents come back together. And there were plenty of examples of this, both plants and animals, that it would make a lot more sense how these animals, and these were not oceanic swimming animals. These were just things like reptiles or plants, and had no easy way of getting from one continent to the other. And another thing that seemed to support this idea of continental drift were these widely separated areas of geologic rock formations. So if we look at rock formations like the Appalachian Mountains in northeastern United States, we see a record of rocks of different ages that were laid down, kind of like layers of a cake. And then if we look over in Scotland and Ireland and up into Norway, we see those same types of mountains where we kind of see the same geologic units, but they're widely separated, of course, by the Atlantic Ocean. But if we got rid of the Atlantic Ocean, fit everything back together, then at one point in the past, this could have been one contiguous mountain range, which geologically would make a lot more sense. So the idea of continental drift is like this. We have the mantle below the crust of the Earth, and the mantle is dense material. It's dense rocky material. It's a solid. It's not a liquid, but it's dense rocky material. And on top of that, we have oceanic crust and continental crust. The idea was the oceanic crust is more dense, and that's true. So it doesn't float as high on the mantle. And by float, I mean, let's take a look at this iceberg here, right? I think most people know that an iceberg, there's a lot more below the iceberg than there is above the iceberg. And that area below is actually supporting this area above because ice happens to be less dense than water. So because it's less dense, part of the ice floats above, and this is something we call buoyancy. And that buoyancy accounts for the difference in density of the liquid water and the solid water. Now let's go back to the continental drift idea. Same thing happening here. The continental crust is less dense than the oceanic crust, so it's buoyed up. It's sticking above the oceanic crust, just like the iceberg sticks above water. And both are being supported on top of the mantle, which is also solid. But this whole idea of isostasy is very important to continental drift. But the other thing about and that all rings true with all the science we know. But the other thing about continental drift is that Wegener said, well, these continents are just kind of breaking through the oceanic crust, like these continental crust is just breaking through the oceanic crust like an icebreaker through ice. And that just cannot happen. The continental crust is not strong enough to break through oceanic crust. There's no reason it would move around like a raft on water. And this was a part of continental drift that just did not make sense.